So the internet connection. I'll share the screen. Just a minute. Is it visible? Hello. Anyone reply?
Yes, sir, visible.
Okay. So the fault location and the system conditions and the fault can cause either the temporary voltage drops or it may be voltage rise here now. So depending on, suppose three-phase line is there for one line, the fault occurs means particular line voltage will be reduced over there. And if any capacitor banks and all the things, if it is suddenly we have added to one line single phase load, because of that single phase loading and all the things, it is going to increase the rise of voltage of the particular line. That is called the rising of the voltage. We are going to call as voltage rise. That is nothing but swell. We are going to call voltage drop. That is called sags. We are going to call our complete loss of voltage. That is called interruptions here. So complete loss of voltages, if voltage came to zero, and that condition we are going to call that is interruption, and it is only small drop is there, that is called voltage drop. That is nothing but sag we are going to call. If voltage rises for some voltage, it is instead of 1.1 per unit like that, it is increased, then that one we are going to call as voltage swell we are going to call here. And if completely the voltage is zero, that is called voltage interruptions we are going to call, or loss of voltage we are going to call that. These three definitions we are going to discuss in the today class here. So first one we will consider the interruptions only here. So the interruptions occurs when the supply voltage or load current, it may be voltage or current, that decreases to less than 0.1 per unit here. See here, 0.1 per unit for a period of time not exceeding 1 minute. If the voltage is reduced or decreased or dropped less than 1 per unit for not exceeding 1 minute, within 1 minute only, if the voltage down to the 0.1, then that one we are going to call it as interruptions we are going to call. So these interruptions occur particularly for the system faults only, it is going to occur. That is, if any equipment it is failure, then that time also it is going to occur. And some control malfunctions are there, if mismatch is occurred, some positive negative reversed on that condition also, it is going to occur here. It is going to operate in three areas or three types. It is going to, the interruptions occur if it is, that is 0.5 to 30 seconds or cycles we are going to consider, not seconds, 30 cycles here now. So one full cycle is nothing but that is this one we are going to call one cycle here, no, like that 0.5 this half cycle to the 30 cycles we are going to consider this one here. 30 cycles, that is nothing but instantaneous fault we are going to call that. That is instantaneous fault here. So momentary fault is nothing but from 30 cycles to the 3 seconds. We are going to consider the time here now. So 30 seconds ko kitna time lete, 30 cycles, that one, to next up to 3 seconds, that is called momentary reason we are going to call that one. Momentary reason we are going to call. If it is 3 seconds to 1 minute, up to the 1 minute, if the interruptions occurs, that one comes under the temporary, it is going to come under that. That is temporary, it is going to come under that. So these are the interruptions we are going to call that one. Similarly, if there is a loss of voltage, if it is decreased to less than 0.1 per unit, that is called interruptions we are going to call that one. Suppose only small drop is there, that is nothing but the voltage will decreases from 0.9 to 0.1. 0.9 to 0.1, that is called voltage sags or dips we are going to call that. Voltage dip we are going to call, or voltage sag we are going to call that one. if the voltage will drop from 0.9 to 0.1 per unit, so that one we are going to call as voltage sag. We are going to call that one. That is called voltage sag or dip here now. So that too, a sag is it decreases to between 0.1 to 0.9 per unit in RMS voltage or current at power frequency here now. The frequency should be power frequency. Otherwise, we are going to call that one as interruptions and all the things. So power frequency for durations 0.5 cycle to 1 minute here. So starts from 0.5 cycle and up to the 1 minute, it is duration is there. During that one, it should have to what is that one? The voltage, if it is 0.1 to 0.9, it is false, then that one we are going to call as voltage sag or voltage dip we are going to call it. So sag durations are subdivided here into 3 categories here. Again, I told whatever the interruptions we have discussed just now, these interruptions also 3 categories we have divided: instantaneous, temporary, momentary, and instantaneous. So like that, here also instantaneous, momentary, and temporary 3 categories are divided here now. This duration based on the duration, instantaneous, momentary, and temporary here now. So the causes for the voltage sag is nothing but energization of heavy loads or starting up the large motor. Suddenly we are going to start the large motors, it is going to consume the more electricity, it is going to consume. Suddenly the power is added is nothing but that will causes the voltage dip we are going to call that one, or voltage sag we are going to call that one. So these are categorized into 3. The instantaneous means the magnitude of voltage is same for instantaneous, momentary, and temporary here. The magnitude of the voltage or current, it may be same 0.1 to 0.9 per unit only, but the duration will changes here now. The duration is suppose 0.5 cycle, half cycle to the 30 cycles it is going to consider, that is called instantaneous. If it is momentary, from 30 cycles to up to 3 seconds you consider. From 3 seconds, that is 0.5 seconds to the 3 seconds you can consider. From 3 seconds, 0.5, that is 30 cycles to the 3 seconds, that is called momentary we are going to consider. And from 3 seconds to 1 minute, it is there, that is the temporary voltage sag or dip we are going to call that one. This is instantaneous. For particular instant only it is going to come over there. From 0.5 cycles to here, somewhere it is down only for particular cycle. If it is there, that is called instantaneous we are going to call it. Particular movement, that is called moment we are going to call that. And temporary means anywhere in between from time 3 seconds to 1 minute it is there, that is temporary fault is there. If more than 1 minute, again you can call that one as a sustained interruptions we are going to call that one. So interruptions we are going to call that one. Yeah. This is called voltage sag, we are going to call this one. Next is swell, voltage swell we are going to call. If the voltage will drops, that is called sag we have considered. If voltage will rises, actually before 1 per unit, it is up to the 1.1 per unit, it is rising from 1.1 to 1.8 per unit here now. So that is called the voltage swell we are going to call it. So swell is defined as an increase in voltage or current between 1.1 to 1.8 per unit in RMS voltage or current at the power frequency for a durations from 0.5 cycles to 1 minute here now. The duration is same for voltage sag and swell here, but the voltage variation will be there. For the down, or what is that one? For the sag, it is varying from 0.5 cycles to 0.5 cycles to 1 minute only. The duration is same only, but the voltage is varying from 0.9 to 0.1. 0.9 to 0.1. Under this category, it may fall. Suppose voltage 0.6 is there. It is voltage sag only here now. For 1 second it is there. It is sag only. It will come under the, if momentary it is going to come over. That 1 second is there. Up to 3 seconds we are going to consider. Suppose for 1 cycle, we are going to call for 1 cycle it has, suppose the 0.2 per unit here now. That is called instantaneous voltage drop we are going to call it. Like that, the voltage sags will be occurs in 3 categories based on that here. So swells are nothing but if the voltage will be increases from 1.1 to 1.8 per unit here. Now the rise in RMS voltage or current from 1.1 to 1.8 at power frequency. So the duration from 0.5 to 1 minute here. So causes of voltage swell again here, no temporary voltage rise here on the unfaulted phases here now. During unfaulted phases, suppose single line to ground fault occurs here, no, but unfaulted lines are there, that line's voltage will be increases. And switching of a large load, suddenly we are switching a large load, then what will happen? The voltage dip or voltage sag will occur. Suddenly switching off the large load, voltage swell will occurs over there here now, and energizing a large capacitor bank. We are going to energize that one, because of that one the capacitor bank also it is going to generate the reactive power over there. So based on that, the voltage swell will be occurs over there. Voltage swell will be occurs over there. Suppose I will tell that one for 2 seconds. For 2 seconds, what will happen? The voltage will be around 0.7. It will comes under what here now? Can anyone tell me? 0.7 per unit voltage is there for 2 seconds. Yes? Any one of you? And 1.7 voltage is there. 1.7 per unit for again 2 seconds here. Again 2 seconds. In this one, which one is voltage sag? Which one is voltage swell? Rule number 1, Shraddha. You only tell the answer.
Yes, sir.
Here, for 1 voltage is there 0.7 per unit at for 2 seconds. Duration is 2 seconds. Here 1.7 per unit for 2 seconds here. In these two, which one is voltage sag? Which one is voltage swell? Shraddha, I'm asking to you only. I'm asking to you only. Payal, are you there? Payal Salgare?
Yes, sir.
Tell me, madam.
0.7 swell sag per unit.
This is swell,
Sag.
sag. Then this one?
Swell.
Swell. This type of faults are temporary or a momentary or instantaneous, this one. Here 3 categories I have told: instantaneous, momentary, and instantaneous. All are both they are instantaneous.
Swell का instantaneous आता है sir.
Okay. So instantaneous you are telling on only for, we are not telling for only few cycles. It is in the second I have written up to 2 seconds. So it will come at a momentary UVR, it will come over there. So 30 cycles to the, that is 30 seconds it is now here. Just a minute. I will draw one waveform here now. I will draw one waveform here now. So you can tell the answer for that. See here now, this is this one I will consider as 1 per unit. This one I will consider as 1 per unit here. So in this one, is there any voltage sag and swell? Anyone, can you tell? Is there any voltage sag or swell? Gayatri, are you there? Ekatpure. Gayatri, Ekatpure. From this diagram, can you tell me, is there any swell or sag? Any one of you? See here, this is the diagram. The sinusoidal waveform I have drawn here. See, 1 per unit we have to maintain, but for one cycle, half cycle, it is okay. Another half cycle, it is okay. For the next cycle, suddenly the voltage is dropped here now. It is not 1 per unit. Again, for the next cycle, the voltage will be normal over there. So this is called instantaneous, we are going to call here. From 0.5 to 30 cycles, like this here, 1 cycle, 2 cycle, 3 cycle, 4 cycle, 5, 6, like that. Up to 30 cycles, if anywhere the voltage drop is occurs, that is called instantaneous voltage sag, we are going to call that one. That one we are going to call as instantaneous voltage sag, we are going to call. If anywhere suddenly, what will happen? I will take the white color now. Here, see, this is normal voltage drop. We'll consider. For the second one, suddenly it will go up over there. So for the third one, normal it will come over there. See here, this is instantaneous, we are going to consider. This one is actually 1 per unit. But for second cycle, the voltage is increased here now. Increased means the voltage is raised here now. So this is called instantaneous swelling, we are going to call that one. Instantaneous swell we are going to call. This is sag, we are going to call that one. Voltage sag and voltage swell we have discussed here now. Only for the up to this 30 cycles, if any problems occur, that is called instantaneous. From 1 second, you consider 0.3 seconds to 0.3 seconds to the 3 seconds, that is called, it will comes under momentary. And if it is more than 3 seconds, that will comes under temporary here now. It may be voltage sag or it may be voltage swell here. Okay, is it clear now, Shraddha, Payal?
Yes, sir.
Okay. So next we will go for, see here, this is the diagram. Actually, one graph is there here. This is the nominal voltage, whatever the nominal or standard voltage is there, it should have to maintain under this one only here. 1 per unit we have to maintain. Suppose if it is more than 1 per unit, that is called temporary, momentary, instantaneous. From 0.3 cycle, 0.5 cycles to the 30 cycles, that is called temporary or instantaneous swell, we are going to call. From 30 seconds cycles to the 3 seconds, that is momentary swell. And if it is more than 3 seconds, that is called temporary swell, we are going to call. If more than 1 minute, up to 1 minute is there, see, this one is greater than 1 minute is there, that one we are going to call as, what is this one? If the duration is greater than 1, that is called over voltage, we are going to call. If it is less than 0.1 second, that is called transients, we are going to call that one here. If the voltage is more than 1 per unit for less than 1 second, that is called transients. Okay, 0.5 to 30 cycles, that is called instantaneous swell. 30 cycles to the 3 seconds, that is called momentary swell. 3 seconds to the 1 minute, that is called temporary swell. If it is more than 1 minute, that one we are going to call as over voltage, we are going to call that one. So that is more than 1 per minute. These are all the things. Suppose instead of more than 1 minute, 1 per minute, if it is less than 1 per minute or 0.5 to 0.1, on that condition, if it is less than 1 second, that is called transients, we are going to call. If it is 0.1 to 0.5 to 30 cycles, that is called instantaneous sag, we are going to call. That is 30 cycles to the 3 seconds, that is called momentary sag, we are going to call. If it is 3 seconds to 1 minute, that is called temporary sag, we are going to call. If it is more than 1 minute, greater than 1 minute, there is a voltage drop, that one we are going to call as under voltage here. Now, under voltage we are going to call here. So if it is less than 0.1 per unit, suppose less than 0.1 per unit, that is instantaneous interruptions, momentary interruptions, temporary interruptions, and sustained interruptions here. Now, these many causes will come over there. So whatever we have discussed up to this one, over voltage, under voltage, sustained interruptions, normal interruptions, transients, that's instantaneous, momentary, and temporary voltage sag and swell, these all the things it is going to represent by using this one single diagram. If you remember this diagram, you can explain all the things here. Now you can explain under voltage, you can explain over voltage, you can explain that is temporary, momentary, and instantaneous voltage sag and swell, as well as the transients also you can explain here. You can explain these transients also. Okay, is there any doubt? Have any doubts here? So no. It completes long voltage during variations and short voltage variations here now. Now we will go for the voltage imbalance, we are going to call here. This voltage imbalance, it is very simple to understand for all of you people here now. Okay. So example, I will take all of you in your houses, you are going to use 3-phase or single-phase supply. In your houses, you are going to use single-phase supply or 3-phase supply. You are going to use the electricity means your house is load for the electricity board. You are going to add some load. That load is 3-phase load or single-phase load. All of you are using iron box. घर में iron box है क्या? Yes or no? सर क्वेश्चन मत पूछो, एक्सप्लेन करना है तो करो, मत करो. Shivani, are you there? Maharnavar. Pujari Sangeeta. Sangeeta Pujari. Unmute please. Sangeeta Pujari. Second time call. Third time I called means you, if you not replied, I will remove and I will put absent. Sangeeta Pujari, are you there? Unable to unmute. Everyone is getting problem with the same. Okay, leave that one. So these type of voltage imbalances, actually it will comes for the single phase loading only. So up to your transformer, what will happen? You will get the supply output of the transformer here. The pole mounted transformer is there. You are going to take 3 lines RYV from the substations here. Okay, from the substations you are going to take. You will get 3-phase 4-line output you are going to get from the transformer. That is distribution transformer we are going to use it now. So here one circle here, in a circle we have fixed the transformer means whatever the persons they are staying here, they are going to use one phase and neutral here now. And this area persons they are going to use another phase and one neutral here now. And this area persons they are going to use another phase and neutral here. Like that, the load is distributed here now. 3-phase load is distributed into single phase load here now. Single phase load here now. So for that reason, one phase, suppose एक area में all 4 members, they went to vacation trip and all the things, they are not utilizing any supply. And that condition, only 2 phases are overloaded over there. So in that condition, the voltage imbalance will be occurs. The voltage imbalance will be occurs over there here now. That is nothing but voltage imbalance. We are going to call that voltage imbalance. 3-phase supply we are getting means, so all the lines are phase to neutral. This one I will use the neutral line here now. So equally it should have to distribute the loads over there. Whenever you are going to design for the house wiring and all the things, on that situation you have to think this one here now. The load should be equally distributed for all the phases. Single phase load, for suppose you are having a 3-floor building, 3-floor ka building hai. Each phase one floor you are going to use over there. For first phase R, second floor Y, third floor we can use, that is B here now. Okay. So this one we are going to call as voltage imbalance. We are going to call here. Voltage imbalance, also called as voltage unbalance, is sometimes defined as the maximum deviation from the average of 3-phase voltages or currents divided by average voltage of 3-phase voltages or current here. Expressed in percentage, we are going to call that one. So 99% all are matching. There is no imbalance is there, like that we can call that one here. Imbalance is more rigorously defined in the standards using symmetrical components we are going to use. So the ratio of either negative or zero sequence component to the positive sequence component can be used to specify the percentage of unbalance here now. So zero sequence or negative sequence to the positive sequence component, we have to do that one, the ratio. It will give the specific percentage of unbalance it is going to give here now. So causes for the unbalance is the primary source of voltage, that is called unbalance of less than 2% is single phase load on a 3-phase circuit here. If it is less than 2%, the primary source of voltage unbalance is less than 2%. That is called because of single phase load on the 3-phase circuit. 3-phase circuit को हमने single phase का load add की. That is called 2% of the voltage unbalance will be there. Voltage unbalance can also be result from the blown fuses in the one phase of the circuit. Transformer also it has one dual voltage score. I think the fuses, it has fuses, duals and all the things. If one fuse is blown out, another 2 phases they are going to give the supply, another one it is not giving here. No, on that conditions also, if it is voltage unbalance will be there here. No. So severe voltage unbalance, if it is greater than 5%, can result from the single phasing conditions. If it is up to 2%, then that is called no problem, because we are using a single phase load to the 3-phase, that is okay. Now if it is more than 5% voltage unbalance is there, that is called serious or severe issue will be there. So we have to balance the loads over there here. So I think you have studied your 2 wattmeter power factor for balanced load, 3 wattmeter method for the an unbalanced balanced load. You have studied about that. All 3 phases should be, we have to add equal load, we have to add over that. We have to add the equal load. That is called voltage imbalance we are going to call here. So I will show some diagrams here. No, see here, this is the diagram. So suddenly the voltage is increased here. No, it is decreased, increased, decreased, increased. So voltage unbalance we are going to call that one here. Is there any balance here? No, एक ही जैसा है क्या output voltage? No, that is 1 per unit है, इधर 1.5, 2 हो गए, 2.5 up to 3 also it is there. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Monday. Again, from 1 week, the voltage unbalance trend for residential only, they have considered residency only. Okay, example I have taken here, the transformer is there. Okay, it will एक line इधर दिया है, एक line आपका फ्रेंड के घर में दिया है, एक line इधर दिया है. Okay, so वो भी छोड़ दो अभी. 3 lines are there. I told that one, this is the ground floor, first floor and second floor here. Now for the ground floor, I have given R and neutral, R phase and neutral. Second force I have given Y and neutral. For the third floor, I have given B and neutral here. So in the ground floor you are staying. For the first floor you have given for the rent over there. So suddenly what will happen due to some festival and of all the people, these two persons, they will lock their houses and they will go to their trip or vacations, they will go over there. So only you are using here. No, you are going to use only R phase here. That is imbalance only we are going to call. Here they are not using, you are using the electricity. That is called imbalance only. Yes or no? So while designing a house, you have to prefer first, you have to calculate the load with the requirement of time. Suppose the AC you are using all the places. Suppose 3 ACs you are using means for the all 3 phases you can give one phase, one AC here. No problem. That is not a problem here. So alternately you have to give. Suppose washing machine you are going to use, alternately you have to give एक R phase का इधर ये R दिया तो इधर Y देने का, इधर B दिया तो इधर. So alternately they have to use that one. So we have to make that one balance. So to make the balance bridge, we should know that for the designing purpose, you should know that one when they are going to run the washing machine, when they are going to use the AC, when they are going to run the fridges and all the things. Then only we can make the balanced load over there. We have to distribute the loads equally. You have to balance the load. You have to distribute over there. So voltage imbalance we have discussed, and in the tomorrow class we will discuss about waveform distortion here. No, so waveform distortion is nothing but it is defined as the steady state deviation here. If in your output you have any DC output is there, DC part is there, that is called DC offset we are going to call it. The harmonics are present here now. For the more than less than 200 kilohertz frequency, if any integer value is multiplied, that is called harmonics we are going to call here. That is harmonics are there in the output form, that is waveform, that is waveform distortion will be occurs over there. Interharmonics, there is a harmonics, but they are not, we are not multiplying into the integer value here now. So at power frequency only it is going to give the produces the harmonics. Those type of harmonics we are going to call as interharmonics we are going to call. Suddenly some places due to the non-linearity of that one, some notches will be there. So that is called notching or flickers will come over there. The noise will be there. So that one we will discuss in the DC offset means what, harmonics means what, interharmonics means what, notching, noise. These all the things we will discuss in the tomorrow class. I will stop here. We'll stop here only and we'll continue in the next class.